Right, this is ytterbium, again lanthanide, stored in a very old glass bottle.
Ytterbium is one of 3 lanthanides which was named after a Swedish town called Ytterby, which is where they were all discovered. Terbium, erbium and ytterbium are all derivatives of that town name.
Oh, the town's done well out of itself, hasn't it?
The town's done very well out of it, yeah.
Have you ever been there?
No, not personally.
You should go.
Yeah, I should.
It's quite moving and quite stirring to be here in this place, because this is where science and industry came together for one of the earliest times, I suppose, and quite a significant place of discovery and an economic vibrancy for the local area. It's almost spiritual. It's really quite different.
What does it look like?
Ytterbium. It depends on whether you're talking about the metal or as an element. Often ytterbium-2 compounds are sort of yellows and oranges. Where do I get it from? Yeah. Buy it from a catalogue.
So ytterbium, it's a rare earth element, it's a metal, it's a silvery lustrous metal, it's very soft and it reacts very readily with oxygen to form a very nice protective oxide layer which sits over the metal, so it preserves itself after reaction with oxygen. It was first identified or first isolated from a sample of a mineral which was recovered from this very quarry where we are in Ytterby near Stockholm in Sweden. But it took a very, very long time to make that extraction and to purify the metal. It's a rare earth element, it's one of 15, and it's actually the least abundant of the rare earths. But the name rare earth sort of makes you think that it's really rare. But if you look at its occurrence in the Earth's crust, it was a surprise to find that actually it's twice as abundant as tin. But that said, total production of ytterbium is only 50 tonnes per year. So it's still very, very little utilised, and that's probably because its chemistry is least understood. And it's least understood because we were only really able to isolate significant amounts of ytterbium in the late 1950s. Like many other rare earth elements, its main applications lie in the electronics industry. It's used as a dopant for phosphors. It's used as a dopant in ceramic capacitors and other electronic devices. So really niche applications, but research is broadening those applications day on day. The metal itself is really quite unusual because its properties change as a function of pressure. So it's a metal, so it's a conductor. But when you push it under extreme pressures, so 14,000 atmospheres of pressure, it becomes a semiconductor. And that semiconductor ability changes as a function of temperature. So it's used as a pressure sensor in extreme environments. And in fact, one of the major applications is in electronic devices for the monitoring and sort of measurement of pressure, especially within nuclear explosions. So quite a significant element and quite a recent discovery.